All right. So, first things first. Let's have an audio check. Is my audio clear? My video, everything. Okay, that's a yes from Rian. How about the others? All right. Okay, two. So it seems that there's only one, two, three. There's only four of us here for today. So yeah, we'll have to make it's here. Um, right. I don't know if you guys have noticed, but I was late in uploading the recording because it seems that I wasn't able to record the correct microphone from last time. So the audio might be a bit low. Okay, so I was trying to look for a way to um, boost it up without without boosting the noise as well, but it turns out to be a bit more complicated. So yeah, you'll have to increase the volume when you're viewing that video, and but at least the video is it recorded the correct one, the correct window. So yeah, it's under here. I separated into recordings, so I'll be putting all the recording here in this group recordings, and then each topic it will be a separate group. So for today, we're gonna discuss these two PowerPoints that we have here. Hopefully, we can finish this today. There's quite a lot of things to discuss here. But yeah, if we can finish this one, maybe we'll have some time for some activities. Okay. Yeah, that's it. What else? So as I'm adjusting this one, making changes, you will also be receiving notifications via email. So yeah, you'll be notified once I upload a recording, PowerPoints, and whatnot directly. Okay, and that's it. Okay, so that's that. Recording is on. All right. Okay, I think everything is good to go. Let's go ahead and open up our Jupyter Notebook. So I hope you guys explored Python a little bit um, when you had some free time, since it would help you greatly. You did some advanced reading, and you can ask some questions or clarifications during our discussion. If you can't like have the activities today, then I'll maybe send that one to you guys as a sort of an assignment that you can go over it the entire week. Uh, let's see. Mm, yeah, okay. So I'll be using the same notebook throughout our sessions, right? And then I'll just be updating the one in the LMS, right? Anyway, you'll see there when was the last upload that I did, so you'll know if it's the current one or not. Okay. A quick review of what we did last week. We did a quick um, breeze through the history, a little bit of history of programming and algorithms and those things, hardware, software, and then we got an introduction into functions, right? They're really one of the most basic functions in Python, which is the print function. We discussed how to read it, how to read the syntax, how to use the syntax, what are different parts of those things, the parameters, the arguments. Um, let's see, how to read the documentation, right? What were the different data types? And aside from the print, we also learned input, the input function, And later on in the end, at the ending part, we saw that in the purport there was an int function, right? An int function and also a float function, right? And the way that they work is that you pass any kind of text, right? So if it's text, they are obviously in string format. So the data type is a string, and then it will be converted into a number, all right? So yeah, um, so Python itself, right? Programming languages themselves, the higher level ones, are very flexible when it comes to arguments, right? To the point that you can also pass functions as an argument, okay? Especially if those functions have a return type, all right? So I think we discussed this one before. Return. Yep, we discussed this one because we discussed the input, right? So when you hear the word return, it you can just think of it like it essentially replaced that function with the result that it got. Okay, so the place where you call the function, where you were using the function, the value that will result with that function will be placed in the exact same position. So if we put the input here, its return value is whatever the user will input. So it will pass that back to this location, or in short, it will return to where the function was called. Okay, and it puts that here. After that, Python can then proceed to the next part of the code, which is okay, the function is done. Now what's next? So Python will see that we are assigning that value, the return value, into a variable, right? So the variable is named name. And from then on, we can just refer to the name variable to access whatever that data was, okay? Not just, it's not just a simple string. It can be as complex as uh, a larger data set, or for example, a complete description of something. Okay, but we'll get to that later. Right now, we'll focus more on the theories on what it's used for, and from here on out, it's actually a lot easier to expand, right? Once you understand uh, the foundations, it's easy to expand into the more advanced topics, right? Just like with anything in life that you do. We often start with the simple things, right? The theory first. Um, let's see. So I asked you last time if you have any questions, but you know, there was none. So again, if you have any questions, just raise them up and call my attention. Or if you want, you can just leave it on the chat, and I'll get to it when I see it. What else? Okay, I think we can proceed now to this one. So, loops and selection statements, right? Oh, by the way, we only discussed a few functions, but there are a lot of functions in Python, right? We don't have to learn all of them right now, but if you guys have some kind of like question or something that you want to do, it's better to assume that um, maybe Python already has that kind of function available. Okay. Um, like I said before, the dry coding principle. So avoid repeating yourself. Um, if the code or if something exists already that answers your questions or that gives you what you want, it's better to use that one. It's faster to learn that one rather than uh, you know make it yourself. It's more time consuming that way. And what else? It has been tested. It has been viewed by other programmers also, so they can you can be assured that it works well compared to when you make it yourself. Um, so yeah, that's it. Okay, so we'll go now to loops. Let's see. Alright, so repetition statements or loops repeats an action. Each repetition of an action is known as a pass or an iteration. Alright, so there are two types of loops. We have definite and indefinite. So from the name itself, definite has a certain end, while indefinite has it has a way to end, but it depends on the condition, right? So the first thing that we need to know is why do we even need a loop, right? So let's assume that we have a certain code somewhere. Um, let's see. Let's just use pseudocode for this one, right? Okay. That's wrong. Let's be yeah. So let's assume that we'll have some kind of pseudocode. First is we want to, let's say, accept user input, user input, and where is the screen? Oh, okay, it's not markdown. All right. First is accept user input for, let's say, name, age, and address. Just those three for now. Okay. Next is what do you do? For each input, you convert them accordingly to their data types. So name is already a string, address is still a string, but for age, oh no, wait, I think there's something better. We can separate the name into first name, middle name, last name. Okay? So take note, I'm not writing code. This is just pseudocode or yeah, pseudocode, but this is actually the algorithm, the series of steps that our code should take, right? Actual pseudocode is more like we're using code words similar to programming, but not really. Yeah. Yeah, we'll get to that. So let's start with the algorithm. Okay, and then we'll go to the pseudocode, and then the actual code. Algorithm, pseudocode, and then yeah, let's start with the this is like process mapping. Hmm, process map. I think kind of yes. I think we can uh, put it in the same category as that one. Yeah, but in a different context. So three, actually we're gonna separate. What else can we do? We can what? Change data type. Sorry about my keyboard. Change data type of age into number. Separate address into city, city, province. What's that? Zip. All right. So let's say those are the four steps. Okay, we'll do those four steps, right? So these steps are just general steps. Okay, the actual algorithm for this you can go real deeper into this and um, you know expand this one some more, but let's stick to the general uh, subject, general algorithm. Now the pseudocode for this is it will look something like this. So accept user input. All right, so we're gonna say like we have name, age, address, right? So we can say let's say this one to a name variable, right? All programming languages have a name variable. We'll say input. We're not really sure if input is the name of the function. We'll just assuming that it is. And then you will pass in here uh, as or ask the user. All right. Next is we'll have the age. Next is input, and then ask the user again. So at this point, you can see kind of the same trend, right? So address, input, then ask the user. Okay, so there's one thing that's different each time, right? So it's uh, it's assigned to different variables, but the code that it is executing is basically the same, right? It's just assigning it to different variables, but this is the same. At this point, you can actually transform this one into a loop, right? And all you have to do then is to find a way that it will assign the values that it gets from these inputs to those different variables. There's a lot of ways that you can do that, but let's not get there for now. First, focus on the concept. All right, now we have the name, age, address, right? Next is separate the, okay, that's done. Change data type of age into number. Okay, so we can say um, age number, right? We'll assign it to a new variable. We can say change type function age, right? Age that is a string, and then after that, this becomes a number. So we'll maybe put a comment here or something like that. It becomes a number after that one. The name of the function is not really change type. It's more like you have some kind of guide on what your program should do after that step, right? So we have change data into number, right? Next is separate the address into city, province, and zip. So how do we separate that one, right? What's the algorithm for that? Maybe we can say, mm, let's see, we can instruct Python to split the string, or let's say, all right, how about this one? Let's see, split address. Let's save it to a variable named split address. Then let's say there is a split function in Python, and in there, what are we going to do? It needs the address, right? And then after that, what is the return? So we're going to expect that the return will separate it into city, province, and zip, right? How will it know? So it might need some kind of separator. So maybe we can say that use comma as the separator, right? So when you think about that one, you can indeed separate the address into their respective parts if you separate them using the comma, right? But this is assuming that the user, right, is mm, how do I say this? The way that the user typed the address was also following the correct grammar, the grammar rules. So he put the correct commas, the exact order, um, so on and so forth. So usually you start with street number and then subdivision, and then what's after subdivision? You can put the city maybe, and then after that the country. But let's just stick to city, province, and zip. So we are assuming that what are we assuming here? We are assuming that the user is following proper grammar, grammar rules in English, right? Okay, so that is our pseudocode. So this whole thing, right? Um, right now we can make a loop out of this one, right? But actually we can make an entire loop out of all of this, right? So what do we call that loop? Or maybe we'll put it to a certain part and say that that loop, right, is for um, loop is for uh, asking user info. Okay. Now, anytime that uh, you want to say use the same steps, right? All you have to do is what? Copy and paste this entire thing, or instead, you can create a function. That's a lot easier. But the point here is that the loop itself that will keep on asking the user the different infos, it will automatically change the data to number is inside of a loop. So it will do that automatically once you um, put it in the correct code. Okay, now let's proceed. All right. Um, the first loop that we're going to learn is called the for loop, right? And you can see here it looks something like this. So for each pass in range for print, it's alive, and something, and then this is the output, right? This is the basic syntax of how the for loop works. Okay, this form is um, very similar to what other programming languages have as well. So being familiar with this is like saying being familiar with the other languages at the same time. All right. So all you're missing is just the syntax. Okay. The first line of code is sometimes called the loop header. The rest of code is loop body. All right. Now we're gonna take this example and see and dissect each part. Okay. Alright, let's go and make a new cell. Okay, so for loop, right? So for, yeah, let's see. So we have for, I'm still thinking of some different example. Let's see. Alright, let's start with the syntax for now. So the syntax for the for loop is something like this. You start with for, followed by a temporary variable, and then you are followed with in, alright? And then you'll indicate here um, where it will, what um, variable is it gonna loop into. Or if you don't have a variable, you can just pass the data directly in this section and then it will loop over that part. Okay, now let's see. Mm, what will we use? So let's say, for example, we'll use the string for now, any kind of string. Let's start with the string because we haven't really discussed the other data types yet. Strings, right? Um, After that, let's see. We put a colon at the end. So the colon is actually important. Without that, it will produce an error in Python. Okay? And after that, right, is one of the most important concepts in Python. It's called the indentation. So you press one tab key on your keyboard. right? So why do we need to do this? So this indentation, right? Let's say you have um, all of these things. Okay, we'll pass this one here. We'll copy it, paste it here. Okay, so we're gonna say each one is gonna be indented to the right. Okay, now the importance of this indentation is that it indicates groupings in Python. Okay, so it's like you're saying all of these codes, right? Why do I have you show my numbers right there? So from lines 2 to 6, right? You're essentially saying that lines 2 to 6 belongs to group um, line 1. Okay, from line 1. So that's how Python sees your code. Okay, it sees that lines 2 to 6 belongs to line 1. Okay, so other ways of describing this one is what we call nesting. Okay, so there's a lot of concepts in it. Nesting, right? And these codes are nested inside of this code. That means whenever this code is executed, it will follow this, right? 2 until 6. After that, since this is a loop, it has to go back to the top at line 1, right? So that's how it will know up until where that group ends, okay? So if you have other loops, right? What is happening with my screen? Let's see. Let's make a lot of places here. All right. So when you have other loops or loops here, mm, okay, and then a bunch of code, okay, Python will know which code belongs to which group, right? So these codes here belongs to this for loop. These codes here belong to this for loop, right? Right. Another thing is that since we are using a loop, right? So it keeps on repeating the same code over and over again. But the unique thing about a for loop is that it will stop eventually at a certain point. Alright? So what that certain point is, we don't know yet. But it has to finish everything, okay? Everything that this one has, right? Until it comes to the end point. After that, it will proceed to the next line, which is line 7. And then after that, since there's nothing there, it will go to line 8. Okay? So that's the form. Um, let's start with a very simple for, right? So for, right? And then we are thinking of a simple variable. Commonly, what you see in books is they're going to use the letter I. Okay, this is just like kind of habit that we have um, since 90s, I think, or 80s. So for I, right, in. So you indicate here after that um, I for iteration. Yep. So actually, I didn't think of that before. I for iteration. It's what's usually written in books. Right. So after this, you're gonna loop over what, right? What are you trying to loop over with? So let's start with a simple string. I'm gonna loop over my name, okay? Then we'll discuss later what other things you can loop over with. All right. Now, what's happening here is that imagine what you're passing here, right? What you're always passing here is something that you can access the data one by one, right? So let's say this is a string, right? But if you dissect this one further, you have data that is accessed one by one. So you have a letter D, you have a letter A, and a letter N, right? You can access them one by one, um, technically. So what do we do then? So for I here, I is actually a container for each of those individual value um, at that current iteration. So at the first loop, it's gonna access letter D, right? After that loop, it's gonna access letter A, letter N, letter I, letter E, until everything is done, and then it will go directly to the next part of our code. So that's it. So for I, right? If we say print inside of this for loop, and then I will print whatever is inside of I, this is what we will see. Okay? So we will see Daniel, DANIEL. Alright? So any kind of string, right? You can actually access its content one by one using a for loop. Okay? But it's not really limited to a string. Okay? Technically, what it can access is any iterable object. The keyword is iterable. Okay? So it can, oh, there's okay, any iterable object. That is the keyword that you're going to be looking for. Okay? Especially when you are dealing with new libraries, new frameworks, and when you're reading documentation, the moment that you see something like this, iterable object, right? It's gonna be called object no matter what programming language you're in. Okay, as long as it has that description, right? You can use a for loop to access each data that it has. Okay, now this is, let's see, what else? So there are other iterable objects that we have. So we have the list, we have the dictionary, but these are a bit more advanced for us right now at this point. But we'll get to them maybe later around if we finish this PowerPoint, because it's in the next one. I think it's over here. We'll discuss list and dictionaries. Okay, but um, just think of the data, right? The data itself, right? If your data itself has smaller pieces of data, you can use a full loop to access that one. Okay, that's what we're doing here. Okay, um, right. But there are many cases like this one in data science as well. Let's say this. Okay, we'll save the entire data of this user into a single variable, right? And in that variable, what do we have inside the variable? Let's say we have the name, middle name, okay? So you can access each of those names one by one. It doesn't have to be a letter. Each data that it can access can be um, other strings. You can have strings within that smaller pieces of data, right? But I'm getting ahead of myself, right? So let's start here first. Let's start with a simple one, okay? So this whole thing, right, is one big container, and then you have smaller pieces of data inside, okay? It just so happens that our container here is a string, and our pieces of data is a letter, okay? All right. Okay, so since I have access to that data, I can do anything I want to that data at this point of the iteration. Okay, so we said earlier that iteration is uh, the current number of the loop, right? So uh, let's say I'm gonna start at Okay, I'm gonna start at count. Count is equals to 0. And I'm gonna say every time to print count. And then after that, I'm gonna say count plus plus. Will this work? Let's see. Oh yeah. Count. Just do that. Let's see. Alright. So now what's happening here is this. Okay, so I'm trying to print the variable count. At the first point is that's 0. So 0, 1, 2, 3, 4, and 5. So when it goes inside this loop, right? Okay, it gives out the letter D to I, but we're not using the letters, right? The data inside, okay? We're kind of using this one as some sort of count, okay? Now, when it got inside of the loop, okay, this is inside of the loop, it prints count, which is 0. Count is equals to count is 1. So basically, we're just adding 1 to count, okay? This is the very first iteration. But it's not correct because it starts at 0, right? So we should convert this one to 1. Change this into 1, okay? So this is the first iteration, okay? After that, it adds 1 to count, goes back. So after this line, Python goes back to the top to line 3 because this is a loop. It goes to the next data, which is A, all right? But again, we're not using it. Or, okay, how about this one? We can display the I, just so that you guys can follow. See? BANIEL. So at the first iteration, that's 1, it's accessing D. On the second iteration, it's here, number 2, it's accessing A. Okay? On the third iteration, it's accessing N. Okay? And so on and so forth. It stops at 6. Why? Because we're out of smaller data to access in this argument here. Okay, we have come to the end. So that means that a for loop, what? For loop, for loop ends when there is no more data to iterate. Okay, so we have reached the end. And that's how Python will say, okay, the loop is done. We are done repeating these lines of code. It's time to go to the next one. So how do we know that it's going to go to the next one? We'll have, well, let's put a print statement here, okay? And let's say, we'll say outside of loop, right? So at this point, when I run this code, there we go. Okay, so as you can see, the loop here, it has to be executed first, fully. It has to finish entirely before it can proceed to the next line, okay? As you can see right here. So technically, Python will be stuck in this loop until it's done, right? If you have a very long piece of code here, then it will be there for quite a while before it can go to line 9, okay? So that's it about loops. Let's see. Okay. Later on, we have more things that we can put here. Your output was different. All right, let's see. Can you share your screen? Let's see what's different with your code. All right. So you have all right. So can everyone see the code of Brienne? All right. So this is the part where um, indentation becomes important. So remember when I said that the indentation at the beginning indicates the grouping. So essentially, you're trying to say that the print statement is part of the for loop. That's what we're trying to say to Python. So in order for your output to be the same as mine, you have to remove the indentation. See? So now we have the same output. All right. So I hope that clears things up. In a way, it's a lot cleaner, right? If it's like this. Um, before, okay, let me see. Let me share this one back. Right. So if Python is your first language, you might be thinking, well, that's kind of a hassle, right? You keep on being aware of the indentation, but you have to understand that we came from something a bit harder from before. We had to declare each line, right? Something like this, right? You have to have an open curly brace, and on the other end, you have to have another, oh, closing curly brace, right? So this can have any kind of format, right? Imagine this: if your code was something like this, right? Okay, like this. Okay, so it's easier to see because there's only a few lines of code. But what if you have multiple of things like that, right? Okay, like that. And that's without indentation. What if you add indentation to that one? Like this, right? Tracking these things before was a nightmare, right? So that's why coding habits started to happen, okay? So what they did was they have habits like the first opening has to be at the first line or the top line, and then the closing should be after the last line of code for that loop. So they had this kind of habit, okay? So you put another tab here like that, and then another close here to indicate that this is part of that group. Okay, if it's a loop, you have to do it like this. If it's something like a variable, you have to do it like this. Okay. Um, so errors like this are very hard to trace. Why? Because they always come in pairs, like this. Okay, they always come in pairs, and looking for that other pair is um, sometimes a nightmare, right? And that's without the ending statement. So in every ending of the statement, you have to end it with this semicolon, right? If it's a statement, you have to end it with a semicolon. So if you miss one, there's going to be an error in your program. Sometimes it will correctly identify that the error occurred here. Sometimes it doesn't, right? Um, so that's why Python is a lot cleaner when you look at it like this, okay? Python will automatically understand that you are on the next line of code if you just press the enter key, okay? It's that smart. Um, but at the same time, right, you might be thinking, well, there must be a price for these kind of inconvenience. There is. Python is Python is slower compared to other languages. Okay, so the price of that convenience is that it's a lot slow. Okay, but over time, this difference is slowly, disappearing because of faster hardware that we have. Um, so yeah, for me, right, this is a lot easier really to code in Python uh, compared to the other languages. But does that mean that you don't have to learn them? No, because whenever your app, right, or not just an app, it can be a data science, whenever you need something with more power, right? You need more power, like for example, um, apps like Facebook, right? Whenever you need something with more power, they often go back to the more difficult language to code, which is like C, C++, right? So the lower the language, right, the less the computer has to translate your code back to machine language, right? In Python, there's a lot of those layers where it has to convert it for you so that the computer can understand, right? But the lower level that you go, right, the less of those uh, conversions happen. So in a way, it's a lot faster. So other companies have tried this one. Like I'm not really sure about Facebook, but for Facebook, they made their own framework instead of making their own language. For others, they made their own language, um, but only for that, right? Other companies have or are maintaining older versions of their language because they find it, I don't know, it's much more efficient um, for them, right? But yeah, we're getting off topic. So this is how the for loop works, right? Let's see what else did I miss. Can you put a for loop within a for loop? Yes, you can put that one. So just the same concept. All you have to do is put them inside of the loop. Okay, not that one. So let's say I'll copy this one. Okay, so in order for me to correctly put that, okay, so this for loop is inside this for loop, okay? In the same way, it's like a function within a function, right? So if I run this code, what do you think will happen? Okay, so this is what will happen. So in each letter, right, it's gonna repeat my name once. So one, one, let's see, count still remains the same. So it's gonna continue counting up until whatever number is at the end is 42. But it should say my name once for every letter. So D, Daniel, A, Daniel, N, where's N? N, Daniel, right? And so on and so forth. Okay, it's gonna say my name completely once without going back to zero for the variable count and then goes to the next letter. Okay, so again, on the first iteration, when I here is equals to D, right? It has to complete this entire loop before it goes to the next iteration for this loop, which is A, right? So it's kind of like D, right? If I were to write this one out, I could say Daniel first, and then it goes to A here, and then it writes Daniel again. Okay? So that's what's happening. Why did it start with two D's? Alright, so it starts with two D's because okay, we're executing this one, right? So at this point, it says print. So you can see this one directly on the output. It says 1 and letter D. It will add 1 to count, right? So count at this point is equals to 2. Now, the line after this is another for loop. So it says again for I and Daniel, okay? It will print out count I, right? And I is currently D at this point. By the way, the I here is different from the I here, okay? Python will do this automatically for us since this is a loop. But, uh, as a good practice, we should separate or use a different variable for this one. Let's use J in this case. Uh, the entire name. Yes, it took the entire name, but the value for count did not go back to zero. We just kept on increasing it, right? So at this point, right, we are adding 1 to count, so count is equals to 2. At this point, count is already equal to 2. That's why it prints out 2, but J at this point is still D. So that's why we have 1, 2, and then D, and then D. Okay? So whenever you're confused with an output, try to follow the code step by step, and then it's useful sometimes to write out the output at each point. Okay, like this one, you can use comments or you can use a pen and paper, whichever suits you. Yeah, so count at this point is 2, so the output here at the first iteration is 2 and then D, which is what we see here. Okay. Um, yeah, that's it. What else did I miss? Okay, other data types. So aside from string, we haven't discussed list and dictionary yet. What did I have here? Okay, range. All right, let's learn about range. So for range, let's see. All right. Now the range function is, let's see, what's how to describe the range function. Um, let's see. The range function is primarily used to generate like a sequence of numbers. So it's very useful for loops if you want to like if you want to say like I want to create a loop that will uh, that will have 5 iterations or 10 iterations. So a range is a very easy way for us to do that. Instead of like thinking of a string that, let's say, loops 10 times, right? You have to count it manually, the letters. A range is a way for us to easily get around that. We can just say directly, um, range will, a range of 5 will loop 5 times, all right? So if we go and search, let's have it, okay. So if we go ahead and say range Python, let's see, let's use this one. Okay, so just for a quick reference, this is the syntax for the range. So you have range, start, stop, and step. Start and step are optional, stop is required. So that means if we put one number, it will automatically be registered to the stop argument, the stop parameter. So let's use that one. Okay. Um, okay. So let's see. It will returns a sequence of numbers starting from 0 by default. There you go. And increments by 1 by default. So this is 0, this is 1, and stops before a specified number. Right? So let's see. Mm, if we say range of 5, okay, it should give us what? Uh, 6 numbers since it will start at 0, right? So if I have to run this code, alright, that's well. You have to call it out. Range of 5, it will give out. Alright. If we use it inside of a loop, we say I in x, sorry, this is 4, and then we say print I, let's see, alright, there we go. 6 numbers, oh no wait, I'm sorry, the stop. So the stop is um, not inclusive of the stop number. So if it reaches 5, it will stop at 5, and then that's it. It will not include the number 5 in its output. So it's only up to 4, 0 up to 4. All right. Um, let's see. So that's a stop. Let's see. One question that I always get from this is why does it start at 0? Um, it's the way data structures work. So when we get to that point, almost everything in um, data structures, even in other languages, structures start at 0. Okay, and this makes it actually easier for us to loop over certain things using those numbers, right? In fact, you can even access the string and there are smaller pieces of data, which are the letters, using numbers, but we'll get to that. For now, right, we're still in the loop. So, let's see. if you want to say, I want to create a loop that loops 5 times, this is how you should think about the range, right? I want to create a loop that loops 5 times, so you put 5 here. Now this is irrelevant of what will range produce. So for I in range x, usually what you do with this is you want to a different kind of output without using the variable I, right? So let's say you have a certain number count at this point. Count is equals to 1. Okay, so let's say your problem is I want to multiply or add, I want to add 5 to the variable count 5 times. Okay, so I can say count is equals to plus equals to 5. Okay, and then after that loop I'm going to print out the final value of count. Okay, plus equals to 5. Am I using the wrong sequence? Is it plus equals? There you go. Okay, so this is just a shortcut. This is the same, basically the same as saying count is equals to count plus y. Okay, it's similar. Um, so what's happening here, right? So in my mind, I just wanted to create a loop that adds 5 times to the variable count. Okay, so all I have to do is just say range of 5, and automatically I know in my mind that it will create a loop. The loop that we are passing this one to will repeat 5 times. Okay, take note we're not using the value of that um, data, right? We're not using the values 0 to 4. Okay, we're taking advantage of the fact that this is a loop. So you want to create a loop, right? That will do 5 times, right? And that code is just to add 5 to the variable count 5 times, okay? It's not mandatory that you have to use the variable I in this case, okay? You can just satisfy the requirement for the syntax just so that it will create a loop, okay? Now for other uses of range, you have what? Start, stop, and step, right? Okay, so just a quick comparison. The starting default is 0, right? But what if you want to start at 2? So you want to start at 2. Uh, this is what you get, 16, but you can't really see it, right? So we have to print this one out. Print I. Okay, just so that you guys can see. Okay, so 2, 3, and 4 starts at 2 and ends at 4. Okay, the inclusive of 2, not inclusive of 5, the stop parameter. Okay, now what if we add a third argument, which is the step? Um, let's say I want it to start at 2. I want it to stop at 40, not including 40. I don't want to include 40. Right? I want the number 40 to be included, so I'll use 41. And then I want it in steps of 2. Alright? So it will say 2, 4, 6, 8 up until it reaches the stop, so which is 40. Okay? So it will stop at 40, but it will not go over that one because the next one is our stop number is 41. Okay, so once the number reaches over that, it's not going to include it in the output. So that's what we see here. Okay, that's for cases where you are making use of the values that it generates. Okay, what we were doing earlier is that we were making use of the stop parameter to just create a certain number of loops, right? So there's a difference in how we use them, but that's technically how it works. This is technically how range works, right? So it's useful for generating a sequence of numbers. Right. Repair the body. I think that's everything. So you can see here that is doing the same thing as us. It's creating a certain loop number of times and just multiplying the same variable depending on what the value of count is. So it's making use of the values that the range will give out. Let's see. Mm, So this is just a combination about sum. Right. So the problem here is actually very simple. It's summation, right? The question is very simple. What is the sum if you add all the numbers starting from 1 up until 10, right? That's the question that it has here. Now, it might look complicated, but it's actually pretty simple if you dissect it, right? So you have input, so it's going to ask for the lower number. You have int, right? And since we know that input will return the number, okay, or the input from the user here at this point, so we are basically what? Passing a string number into int, okay? So when that string, right, is passed into int, it will be converted into number after. So lower now is actually has the value of 1 as a number, not as a string. The same goes with upper, and then we have the sum variable here, which is set to 0 at the beginning. Then we create the loop, right? So the loop here is we're taking advantage of the range, right? So we are setting the lower bound and then the upper bound of our summation, right? So we want to start at number 1 and then end at 10. So we have a plus 1 here because we want to include the number 10. So that's why we're adding 1. Same thing as I'm doing here with 41, right? Um, the step that it is doing here at this point is default to 1. So 1, 2, 3, up until 10. It's going to add each number up until 10. And the sum after this loop is equals to 55. Okay? By the way, for functions, right? For all functions, okay? So whenever you have a certain expression, right? Okay, so expression, well, this word came from mathematics, right? So uh, something that can be evaluated, so yeah, that can to a single value. Okay, so at this point, 5 plus 5 is an expression, and this can be we can just say that this is the same as print of 10, right? But what Python will do is that you don't have to specifically say separate them, like maybe create a variable here, sum 1 is equals to 5 plus 5, and then you have to use sum. No, you can just directly pass the expression here inside of the function, right? The other one, both of them can be variables, by the way, as long as they have the same data type. The point here is that the way that Python works is that it will always, Python will always evaluate expressions first, okay? And then another trick here is you can think of inside out, right? It starts at the innermost part of your code and then slowly goes out like, okay? So if you have function and a function and a function and a function, it starts at the innermost function first, right? If there are any expressions inside it, it will start with that and then evaluate the function one by one as it goes outside, okay? Um, it's pretty easy to get lost when you have, you know, that kind of setup, function within a function, function, or even loops, right? Loops within a loop within loops. It's very easy to get lost in that kind of code, right? So, but I'm just saying that it's possible. So you might see some codes out there where they are directly performing mathematical expressions inside of the functions because that is actually allowed. And in a way, it produces much cleaner code because you can just do directly the math, right, inside of the function instead of creating a variable. So this is actually very inefficient. Why? Because one thing, it uses one line of code, extra line of code. It uses another variable which consumes resource, right? It consumes memory in your computer, and it's just another step for Python, right? So it's one more step for Python, making it a bit slower. Okay. Um, so yeah, when you reach the point where you're working and making your code more efficient, then these are the things that you have to look for. Which variables are not needed, and then you can just pass the math directly to the function or uh, yeah, function. Let's see. So these are the shortcuts that I was doing earlier. I was doing actually the opposite. That's because in other languages it's actually equal plus. I think, yeah, I think I was using equal plus in something different before. Um, yeah, but it's actually you start first with the operator and then follow with an equal sign. But you know, this and this is basically the same. Um, Technically, they are the same, but in terms of efficiency, the one on the left is much faster compared to the right. But again, we don't really care about that right now. Okay, it's just for technical purposes, right? The one on the left is technically faster than the one on the right. Uh, okay, so why did we have this one? You might be asking. It's because in the 90s, we did not have a surplus of resources. We did not have RAMs that are 16 gigs, 32 gigs, 64 gigs, right? We did not have processors with very high frequencies. We did not have multi-threaded processors at that time. So it was very, very limited, right? To the point where um, before you had to uh, how to say it, you have to declare the size of your variable. So you might right now we're just freely creating variables, right? So sum1 of 505, you can even say directly that what's this? Okay. You can even say name is equals to linear like that. We're directly what assigning values to variables, but it was always not always this easy. Before you had to um, declare the size of the variable, right? At this point, you can pass anything and then Python will automatically assign it for us depending on how big the data we are passing, okay? So if it's just a simple string that is just a very small size, we can even see that one later on. Or it can be as big as you want, like an entire data set that you have saved, right? Which is what data science is, right? It's gonna involve data sets. So let's say you're gonna save an entire column of data, 1,000 rows, into a single variable. You can do that. So Python will automatically adjust the size that it needs for that variable to accommodate the data that you have. All right. So yeah, so declare the size. You also had to declare the type. You have to declare if it's a string, if it's a number, if it's a new data type, which is kind of really a stress. But we have this one automatically. We're not saying that, hey, this should be a number, hey, this should be a string. No, Python recognizes it directly. All right, that's another layer that higher level languages are doing for us, but we don't actually see it anymore. So in a way, um, we are programming more effectively because we are removing those kinds of um, how do I say this blocks that instead of making us focus more, right, on the problem solving part, or getting more focused on, hey, what was the size, the type, which is not really the problem solving part, right? So in Python, we are more focused on the uh, the program itself, right? These things is not anymore needed in Python. All right, let's. Where are we saying, right? Roger. Okay, yeah, this was this one. This is an example of a list, by the way. It has this kind of format. We'll discuss this one later if we have time, if we manage to reach that part. But when you see something like this, it starts with a open bracket and then any kind of data inside will, let's just use numbers, okay? Okay, each data is separated by a comma and then it ends with a closing bracket. When you see this kind of format, this is what we call a list, right? But we'll expand to that one later on, okay? Uh, as well as dictionaries, right? So those are actually the exciting parts. And near the end, you'll start to realize what objects really are. Let's see. Okay, clean character hider, same sequence, this list. So this is a very basic introduction of list, but it's more of a expansion of how range works, not really of how list works. Um, right. It's just trying to see what's inside of range, but you can only do that using the list command, and then it will give you a list return value in order to see what's inside range. But as we have seen earlier, you can just use a for loop to see what the range function will give out. Okay, what are the different values that the range function will give out? All right, let's see. Workout 10 1, right? Okay, same thing. Formatting text for output. Now, is this needed for us? Not really, because we have other libraries that format the text for us. It's a lot more powerful, it's a lot easier. Where do you actually see this one being applied? You actually see this one being applied in um, things like CLI. CLI is short for command and line interface, or what you see before the shell that I demonstrated. Okay. Um, do CLI still exist today? Yes. Particularly in the servers. Um, when you're trying to, let's see, aside from servers, databases, right? Um, and networks, different kinds of networks, right? So um, a CLI is like it should exist everywhere. Okay, we have CLI in all of our devices, even our phones. But do we use it? No, because usually it's represented by a graphical user interface or a GUI. So that's what we see every day. The buttons, right? The buttons, the drop downs, the what else? The choices, right? The option buttons. The option buttons are those circle things, right? Or the check boxes. Okay, so those are graphical user interface. Okay, so we interact with the app using that graphical user interface. Okay, but when you're connecting to servers, right, databases, okay, they don't actually use a graphical user interface. Why? Because this consumes let me see, consumes resources. CLI has the bare minimum of consumption, so that's what we prefer. Other than that, you uh, can be used on any device. When I say any device, I mean any device. So phones, tablets, laptops. These days you have consoles that can act like a device. So you can technically use that one to access command line interfaces and whatnot. There's even smaller versions like the Raspberry Pi, uh, smaller pieces of devices. Okay, so you can access them using command line interface and um, you know, control them, but you're gonna be using code with it, not just clicking and dragging stuff, right? So yeah, um, at that point, right, how is this related to this one? Because you're gonna be asking for certain outputs, right? And your output is also in CLI, so there's not much options that you can do to make it more, pretty, right? So what you can do is just format the text so that it can be read a lot easier, right? So for example, it's this one. It's using the field width or the number of characters, or additional space where you get them in a formatted string. Okay, so in other words, if you want it in a tabular format, you're gonna be using the field width. So using a simple for loop like this, right? Print exponent and multiply it to 10, whatever that exponent is, right? So 7, 10 to the power of how many number of zeros there are at that point of the iteration. So we get 7, 8, 9, and 10, and then the number of zeros here. But it's not aligned properly, right? It's very hard to read this one, especially in a command line interface. Imagine you have a very small laptop or a tablet, and then you're trying to read the data that's going in and out of the server or the database, and like, oh no, this is very hard to read. Like, well, what am I reading at, right? It's easy to get lost when it's formatted like this, but there's actually a way to format that one, and it's this one. So you have the format string, percent, and then data. This is the syntax that we're going to follow for formatting text on the output. All right. Now the format string is this one. Okay. And this is from the name itself, format string. Okay. It is a string describing the format for your data. Okay. So it looks like this. You have minus 3D, percent minus 3D, percent 12D. All right. So this is your format string, followed by what? Percent, and then followed by the data, or what your data is. Okay, what is the actual data that you want to format with this format string? All right. So uh, this is what we have here. So you can just pass this one directly to a print function, and it will automatically format the data to whatever is described here. Okay. Again, you can include directly the, how do I say this, the variables inside of it, and the values will automatically adjust on each iteration. So exponent will change since it comes from the range function. See? So this starts at 7, ends at 10, but not including 11. Alright? So what is minus 3 and D4? Alright? So basically those are indicators. So the first value minus D specifies that it should be left aligned. So that's the minus. You are saying to Python that format the string to be left aligned. Alright? Um, 3 here is the width of the characters, right? So, right, so width of 3 characters, and then the D indicates the value that should be formatted as a, let's see, mm, yeah, D stands for decimal, so we are um, formatting this one in decimal format. All right. So all in all, we want it to be left aligned with uh, three characters in decimal format. So this is for the what the first argument, okay, which is this one exponent. It should be in this format. So the width of the data here, we are assigning three character widths. Okay. For the next one exponent, we are assigning 12, right? So let's see the result of this. Okay, it's not indicated here. Alright, let's just do that one. Okay, so if we um, let's see, for exponent is equals to range. Oh no, wait, in range. What was that? 711, right? And then what do? We print of minus 3D percent minus 3D, right? Oh wait, we have to use double quotes. 3D percent, 12D percent. Was there another percent? Oh no, there's 2%. So that's the end. Uh, yeah. So that 1% and then the datum. So exponent, right? And then exponent to the power of, I mean, it's 10. It's 10 to the power of exponent. And then we have another closing bracket, parenthesis, I think, sorry. Okay, yeah. For a supported format of D, okay, yeah. So take note, you have to use a small letter. Okay, so take note, this is our output, right? It's very different from what we have here. It's because this was written in what? This was written in PowerPoint. So the text is automatically like this, but the actual output looks like this, right? So minus 3D, right? And we have 7 here, but it has one extra space. If I highlight, there's one extra space here, right? Because we are what? We are assigning three digits, right? Three digits, three widths, three character widths for this data, for the exponent data. Next is we need 12. So 12, right? So if you count this one, this is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that's 11. And then if you highlight this one, there's another extra one here, right? See, there's an extra space. That's the 12th one. All right. And so in a way, it's printed more. It's a lot more readable, right? Like, but if you were to print this one out without the format, it will look something like this. Okay, and that's what you saw here. Okay, so it was not invented here on the output. But yeah, this is how it looks like. This is what it should look like if you format. Okay, so this is a lot easier to read now compared to this one because all the numbers are aligned properly. Okay, what happens? Okay, the common question is what will happen, sir, if it goes over the number of digits? So let's try that one. Let's start at, this is 11, right? Let's try 15. So it should go back, should go over 12, right? So if we run this one, this is what will happen. So it will automatically go back to default. It will left align and then add the extra characters to the right, like this. Okay. The same thing can happen also to the first argument. Okay. So likewise. Um, yeah, again, that's it. You don't really see this one used a lot in data science. It's mostly reserved for when you're creating something for the server or you're accessing data from the server. But when you're accessing data from the server, you don't actually output it like this. You take it and then you use another library, let's say one for making charts, and then you use that one to display as an output, right? You're not really using something like this as an output. You want something that looks like a table. The, there's a lot better options than this one, right? Okay, so that's for formatting text. This is just another way of formatting text, but this is with the decimal point, right? So percent filled with, and then dot precision with an F at the end, all right? So F here stands for the float. So your salary, dollar of percent 02, F, so 0.2 here. We're saying that we need to have two decimal places on the output, and then F will indicate the ending as well as the data type. So it's a float, uh, right? So it can be. You can also add some other words. Uh, you don't have to limit yourself in this kind of format. So you can include the formatting together with your string output that you want, right? So yeah, that's why it's included here. And you can see the difference between the top and the bottom, right? The bottom one, there's two zeros, and the top, there's only one zero. So this is for cases where um, you want to prioritize accuracy, okay? So let's just look at a condition, all right? So we're at the point where we're gonna discuss conditions. Okay. Any questions so far, by the way? So there were a lot of concepts that we discussed. Uh, yeah, so some of them might be confusing. If you have any questions, you can raise them before we go to another section. All right. So no questions, we'll proceed. Oh, by the way, we only discussed one type of loop, which is the for loop. But there's another one, which is called the while loop. I think it's somewhere in the next few slides. Um, we'll see, right? But if it's not there, I'll also discuss that. So for loop, and then we have the while loop. But it's still a loop. It technically we should have the same output. It's the way that they end that's the difference. That's the difference between it. Okay. Um, let's see. Let's have a quick 10-minute break. Um, to rest. Actually, for me, to rest because I've been talking for um, almost 2 hours. So yeah, let's have a quick break. 10 minutes. Be back here by 3. That should be enough. Um, and then we'll continue this. I think we're halfway there. And then after that, go to functions, finish this one, and then by next week, we can start um, focusing more on the advanced concepts of Python and then maybe start with Pandas. So we can start with our data science proper, right? We're done with all the foundations, we can go directly to data science proper. All right. See you back here in 3. Shota. All right. So I hope everyone is here. Okay. So it's 3, and we're halfway there for this PowerPoint, and then we'll just do this one. All right. Okay. So um, if and if else statements, right? So based on a certain condition, it's gonna execute a certain code. Okay, so if it's true, it will execute this one. If it's not, then it will execute this group of code. Okay, so how does this work? It uses boolean data type, right? Boolean again is just basically true or false, or 0 and 1. And these are the operators that we'll be using in order to evaluate if something is uh, true or false. Okay, so we're using comparison operators. So equal, not equal to, and so on and so forth. So we all know these um, operations, right? They're basic mathematical comparison operators. Okay. All right. So this is how this is how a if statement works, right? So basically, you start with a condition, and then if that condition is true, it will execute these statements. Else, if the condition is false, it will execute these statements, right? So a statement is just a line of code, basically. Okay. So let's say, for example, we have uh, age, right? And we'll set the age, the variable age to 18. All right. Now you want to say like there's a certain part in your program where a decision has to be made, right? Like um, it has to decide whether it will do something or something else. Okay. Let's say that our problem is if you're 18, you're allowed to drive. If you're below 18, you are not allowed to drive. Okay, so something like that. Um, it can be something as simple as that, or it can be way more complex. So, uh, yeah, let's start with if, right? So if, and then you followed by the condition. So what was our condition? If you are over 18. So how do we translate that into code? You say if age is greater than 18. But what if you are 18? So we can say greater than or equal to 18, right? And the syntax that it states here is followed by a colon. So use the colon, all right? Now, if this is true, if this entire condition is true, it will execute the next statements, right? But the statement here has to be indented. Remember the grouping? So you have to indent it once, right, to nest it in the true condition, right? So if true, then if true, right, this is what it will do. It will print out you can drive. Drive, right? let's have a print statement here. Let's say outside of if statements. So right now, since age is greater than 18, right? If this is true, it will print out you can drive. And then after that, this entire thing is done, right? It's a one-time thing. It's not inside of a loop. There's no loops inside, so it will just be executed once. After that, it goes directly to line 7. So print outside of if statements, and that's what we see here on the output. If we change the age to, let's say, 15, right, the only output we will see is outside of its statements, right? It will not execute this one. This will essentially be skipped. Why? Because it will only be executed. This sequence of these statements will only be executed if the condition is true, right? Now, um, can you have two if statements that will say uh, if age is less than 18, right? It will then say um, you cannot drive the cat so that you can see it clearly. Okay, so now if I run this one, it will skip this if statement, but it will run this one. Okay, now um, let's see. So this is when it's greater than 18. This is when it is less than 18, right? So technically, you should not be doing it like this, right? Try to place it in one if condition, in one whole if condition, that one question, right? Don't separate the question into two different conditions, because what could happen is like less than 18. Mm, because anything can happen with age, right? You can do some additional codes in between the two conditions, so that's not really, um, you know, it's you are separating the question into two different questions with different outputs, right? Where in fact your original question is that if you're 18, you can drive. If you're not 18, then you cannot drive. So a better way to do this is to use the else statement. So if and then else, right? And this is how it works. So the if and the else always align with each other. See? And then after the else, you have to indent, okay, again, the lines of code that you want to belong to else, right? So in this case, you should put this output here. So this is actually a much better way to represent that question. So if you run this code now, you can still see we have the same output, but it's now in just one condition, right? Try to see if you can put your one question into one condition, right? That's usually how it goes, and it's usually a lot easier to trace your code whenever there's an error that occurred. Okay, so again, this is what will be executed if false, right? Take note of the indentations, right? So indent this one so that it belongs to the true condition. The indentations here belong to the false condition, all right? If you have another condition, right? Let's say you have a follow-up question, okay? So you're asking, are you 18, all right? Next is, uh, do you have a license, right? So let's say that let's have another variable here. But this variable can come from any kind, from anywhere, right? This can come from a dataset or a user input, right? So let's say this is true, okay? So if license, take note, I'm still keeping my indentation aligned. So if license is equal true, right? Or we can just skip this one, right? Because what was the condition again? The condition here needs to be evaluated to either true or false. Now the value for license is already binary or boolean, true or false. So we can actually just skip the comparison and then just put license directly here. It will automatically check if it's true or false, right? Because that's what we were trying to get, true or false, correct? So there's no need anymore to compare it to because the value itself is already a true or false. Okay. Next is um, you put a colon here, and then we'll say print, right? Um, so if you have a license, then what do I say? What do you usually say? You can drive, and then if you have a license, I don't know. Wait. Okay. Let's see. You can you can drink. Let's change this one. You can drink. You cannot drive. And then the else here, you cannot drink. All right. And if you don't have a license, you still cannot drive, right? If it's true, it's not making sense, right? So how do we fix this one? If you're 18, you can drink, but if you have a license, you can drive, but don't drink. Won't drink. If you don't have a license, then what? You can't drive. All right, you can't drive. So I'm just making stuff up here. But you know, I'm just trying to show you the point of the if condition, right? So this is an if within an if condition within if condition. So you can treat this one like a follow-up question in real life. So, are you 18? All right. Okay. Are you? Do you have a license? All right. That will only happen if um, this is true, right? You can also put other if statements here. Okay. Um, so yeah, if you run this code now, let's see if license if grade. Okay, so it's not going there because what we set age is equals to 15. So since this was not executed, automatically this is not executed as well, right? Because they are one whole group. But if we change this back to let's say 20, okay, then we will have a different output. You can drink, you can drive, but don't. You can drive. You can drive, but don't drink. I think that makes sense. Okay. Um, right. So this is a follow-up question, right? But what if you have, um, let's say, other conditions that you want to check, right? So our context here is for drinking. So what if you have other questions like, um, let's see, I'm having difficulty. If you say, finish with anything, what other questions would you ask? Like, all right, uh, let's treat this one as you asking the kid if the kid or the person is, let's say the other condition is, all right, so if, all right, let's say, okay, you're under 18, all right, um, let's see. Mm, mm, how about guardian? Right? If you have a guardian, do you have a guardian with you? This is true or false. Um, we'll set this one to false this time. Alright? And then, so this is your kind of like other question right there. Are you under 18? No. So there's still one more chance right before you go to the default value of else. So you have a follow-up question. Do you have a guardian? Right? So how do you integrate this question into this? Right? You only have two choices, right? If not this one, then this one. So if you want to add another condition, right, you can use elif, right? This is short for else if. So else if, right, the guardian, right, is true or false, this is what you will do. We can still say print, uh, still the same, right? Let's say it's still the same output. I can print, okay? And I should move the spaces. Okay, like that. And then if I had to run this code, okay, so let's say it's underage 15, but they have a guardian. Let's set the guardian to true so that it will execute that part. Alright, run. Okay, so you can drink if you have a guardian. There you go. So now this is false, right? And then you're kind of like, okay, so you're under 18, right? Do you have a guardian? So um, if you have a guardian, then of course you can drink, something like that. If this is still false, all right, then that is the time when like the bouncer or the guard will say, then you cannot drink. Then you can see here the print statement is outside of the if statement. This is the entire if statement. This is the entire questions and the possible uh, follow-up questions if there is some, right, inside of it as a nest. So yeah, that's basically how decisions are decided by apps and programs that we keep on using every day. So um, there are like let's see, when you are signing up for maybe an account in a bank, right? Like an online account, Maya, for example, or Gcash, and then they're gonna ask, okay, are you over 18 or what is your age, like something like that, and then um, somewhere in their system, right? If you are over 18, then you should have some kind of government ID. So that's the next thing that they have to verify. Next, okay, what kind of IDs do you have? Do you have SSS? No. Do you have FILA? No. Do you have national ID? Then you say yes. Okay, from that point on, you can um, continue with the process. Okay, it's going to ask you for a picture, front and back, and so on and so forth. So that kind of questioning, right? That kind of sequence is controlled by something called an if conditional statement, like an if, elif, and else statements. All right. So it's basically just a series of conditions, right, behind those apps that we see. Okay. Now I'm saying things in context of apps, but this is still the same thing for data science, right? Because there's going to be questions in data science that you need an if conditions for, like, um, let's say you want data, right? You're trying to research maybe teens, right? So you're trying to isolate data or rows of data that belong to that certain age group. So teen, right? So that starts with what, 13 up to uh, 19, right? Those are the teen years. So within that age group, right, you're gonna have to filter out your data and then remove all the unnecessary data that you don't need. So in this way, you'll have a data set the data set that you're working is uh, how do I say this? It's much more fit to your question that you're trying to answer, whatever that question may be, whatever your research may be. Okay, so yeah, that's one application you can think of for the if condition, right? Now, can you combine this one with a for loop? Yes. Can you combine a for loop with a conditions? Yes. So there are cases where you put if conditions instead of for loops or vice versa, right? You can put uh, even function inside of it, like this one, right? See, so yeah, that's entirely possible, right? Like, okay, I can't think of other examples at this point, but just know that it's possible, right? If you have a loop, and then inside the loop you have if conditions, then that's entirely possible. Okay, let's see here if there are some examples. So this is just a full chart. Um, you might see this one, especially if you are employed in bigger companies, because odds are you're going to be working with multiple departments, and in order to keep track of where everyone is and what your task is, you're going to be following something like this. Okay, so let's say you're assigned to this, your um, code base, your code will do this precisely, and then it will accept this kind of input, and they're expecting that it can generate this kind of output, right? So this just helps everyone to be on the same page per se. So there's a bigger flowchart somewhere, but this is what you are uh, responsible for. Okay. So yeah, not all companies have the same symbols, right? But these are the generic ones. Usually a triangle is um, a question, right? See a question mark. So it's generally for condition statements like this one. It helps you like track where you are in your current program. And also for checking if their outputs are correct. So yeah. So that's for if. This is a multi-way selection, right? So if you have multiple ellipses like this one, so between 80 to 88, this is between 70 to 78, okay, B. So these are the grades, right? Be careful with this one, right? Because when you take a look at it very closely, if you um, mix the priorities, right, of what question to ask first, the output might be different. Okay, so what if I were to swap number greater than 69 with number greater than 89 at this point? So if I were to swap them out, what would happen if the grade of my student was 95, right? it will be it will display the output C. Why? Because it was the one that was first checked. So you have to be careful with the sequence of questions, the sequence of conditions that it will check to have the correct output. Okay, so that's one thing. What else? So it's a fairly straightforward if else. Mm, okay, this one is just taking an input and directly converting it to a number. If it's greater than, then this one. If it's less than zero, then it's this one. So, greater than zero. All right. So it's basically is this code is for uh, controlling the errors, right, or the mistakes that are given by the user. So whenever the user inputs a number that is greater than or below zero, then it's considered an invalid number. So in this way, you are trying to control the errors of the user, okay? Because what would happen? Usually, if this is the case, if you did not have error handling. This is what we call error handling, by the way. Error handling. Zero handling, right? Um, so what would happen is that errors that are not handled will end the program. So this is something that you want to avoid. Why? In data science, let's say you have thousands of rows, right? And then you encounter a certain part where an error occurred, right? So when that error occurred, the program immediately stopped. So that means all the progress that it has done so far will disappear because of that error, because the program stopped. But if you were able to handle errors like this one, then what would happen is that instead of ending the program, it will instead go to that section of the code, run that code, that line, that statement, and then proceed as usual because you are properly handling the error. There's a way for the program to go to. There's somewhere that it can go to so that it will not stop. That's what your error handling is. Okay. Um, so so what? Can you just put a very big if somewhere and then try out for everything? So that's not really practical and not efficient. Usually you put an error control whenever you're expecting some kind of input, right? And when that input is a variable, that means it can be any kind of the return value can be anything. There's a possibility for error. Whenever there is a possibility for error, especially if it comes from a user, then it's best if you put um, ways to control the error like this one, right? But this is a bit more advanced. In the beginning, you can skip this one, right? So it's good practice, yeah, but it's very hard to get, especially if you haven't, um, you're not too familiar with return statements. You haven't gotten enough experience yet with dealing with those kinds of functions, return statements, and values. So you have to really understand it first before you try and go ahead and create error handling because this can get really messy really easily in complex programs, especially if it's a very big program. Okay, now in this case, um, hmm, so it has two conditions, right? But what it's doing is it combined that condition into one thing. So if the number is greater than equal to greater than 100 or if the number is less than 0. So the special thing here is the or operator, okay? So this is what we call a logical operator, right? So in programming, let's see, there are three. So that is the and, the or, and the not, okay? So it's actually very simple, right? Because it works exactly like how it works in English, right? Everything, because I don't know you guys, I don't know if you've noticed this guys, but it's called programming language, right? It is a language, a way for us to speak. So of course, we're basing that one on something that we already know, which is English, right? So how does the and word work in English, right? Let's say, uh, all right, if I say Nick and Brian would need to attend together on the session, right? So in that statement, right, if Nick was here, Nick, right? If Nick was here, and so I'll set this with true, right? And then if Brian is here, let's create some kind of table. So T is for true. So if Nick is here, right, and then Brian is here. Yeah. What's that? So that would mean, right? And we are using the AND operator here. This is where we add. So the output here at this point is what? Since both of them are here, the output is true, right? So if we were to state that in English, Brian and Nick and Brian are here, so that's true. But what if Nick was not on the session and then Brian was there? So Nick is false, Brian is true. So um, based on the and word in English, right? So Nick is not here, right? So even though Brian is here, we cannot proceed with the session, right? Because Nick is not here, right? So automatically the output becomes what? It's false. The session will not go on, right? Now let's do the opposite. If Nick was here in the session, but Brian was not, okay? So what does that mean? If we were to translate that in English, so Nick is here, but Brian is not. So unfortunately, we cannot proceed with the session. So the output is false, right? And then ultimately, if both of them are here, then of course, how will the session start if one is there too at 10? So the session is now false, right? So what does this mean? The AND operator, right, only becomes true if both the left and the right is true, right? So Nick and Brian here are the conditions, and they need to be true. Now go back to the example here. The left condition is number greater than 100, or number is less than 100. Now we were using the and, we were discussing the and, but this is the or, right? Now how does the or work in English? The or works by what? It works by when either one is true, right? So if this is or, right? If Nick or Brian is here, or Nick is here, okay, that's good. Brian is here, okay, that's good. Then we proceed with the session, right? Let's go to the second one. Okay, Nick is not here, unfortunately, but Brian is here. So I guess we can continue with the session. So we say true. Go to the next one. Let's say, hey, Nick is here, but let's see, Brian is not here today, but that's okay. Since Nick is here, right, we can still proceed with the session. And if both of them are not here, then it will be false. Okay? That's how, again, how can we proceed with the session if both of them are not here? So basically, or, right, will only be false if both of the conditions, left and right, are false. So that's what we're doing here. So the the if conditions at the top here, right, we were using more lines compared to this one, where in fact we could have used a simpler expression, right, using logical operators to get a certain range of numbers, right? So it may just be true or false, a simple table like this one, but since we are using comparison operators where the number must be in between, right? Because what are we looking here? We're looking for invalid numbers. Okay, so you can ask two things. You can ask whether something can be true, or you're gonna look for the opposite. You're gonna look if something will be false. If something will be false, or if something will be even invalid, then your condition becomes true, right? If that makes sense. We're looking for the wrong user inputs. See? We're looking for the numbers that are greater than 100 or 0, not within the grades, right? So that's invalid. So why are we looking for that one? Because when you're thinking of a problem, right, sometimes you'll encounter that it's actually easier, much more efficient, and much fewer lines of code if you were to look for something that makes it wrong in the first place, rather than what makes it right. So there are cases like that. Okay, it's not immediately apparent in the beginning when you're trying to code, when you're making the code as you're coding, right? But that's okay because these things often come after you complete the code. After you have a working code, then that is the time where you do something that we call refactoring, right? This is just basically um, making your code more efficient, right? Less lines. Um, what else? Efficient, less lines, better logic, okay, less conditions, okay, anything that can improve your programming speed, programming process, exactly. So maybe there are some certain parts in your algorithm that can be simplified into what instead of 10 lines, 5 lines. So that makes that has a lot of impact, right? So yeah, so that's it. Basically, either one of this code still works. All right. The other one is just more efficient. Okay. Oh, here's another table. Oh, I forgot the not operator. So the not is just basically the opposite. So anything that is true, it will turn to false. Anything that is false, it will turn to true. Now you might be asking what is the point of the not operator, right? So the point of the not operator is if you're looking for something that's false to begin with, right? Okay. Let's say uh, let's say you're looking for anyone that has a criminal history, for example, right? So if you think about it, it's a lot lesser. The list um, gets lesser. The questions becomes lesser if you're looking for that one compared to who doesn't have a criminal history, which is a lot, right? There's a lot of people which doesn't have a criminal history. So how do you identify which one doesn't have, right? Aside from the NBI, there are some other ways, right? So um, if we are looking for uh, the one that makes it false, right? So you're looking for criminal history, right? Does this guy have no criminal history? So if it's a false, right? Um, but we're gonna make it true, so we're erasing not false, so it becomes true. Then that sequence of statements will be executed. Let's say that if this person doesn't have a criminal history, then he can proceed with the flight, for example, something like that, right? Um, but you know, I hope I'm making sense. The one that you're looking for is a false value, right? And when that occurs, then you can turn it to true, right? But you might be asking, sir, why are we just not looking for anything that is equal to false? Um, because in a logical sense, uh, it doesn't match the question that you're asking, right? That's the point. So, um, other than that, what if the, let's say, value changes in a way that can still result to false, right? And you need the statement to be true, the condition to be true in order to be executed, right? So those kinds of conditions are not common, but um, they are still around, okay? So you might encounter them somewhere. But just keep that in mind whenever you see something with a noun. They're trying to get the opposite instead of the one that you usually get. Right? I don't have a definite example right now for that. Maybe I can think of something later. Not has a higher precedence than and or. What does that mean? That means Python will aside from inside and out, right? And aside from uh, expressions, right? Everything that happens in your program has a certain level of precedence, right? Which one will Python execute first? So it turns out that not compared to and or has a higher precedence. That means if the three of them are in the same line, it will run the not operator first, okay, um, before the and or. However, if the not, right, is inside the and, okay, or is outside of the and, right, um, and the and operators are somewhere deeper on the nest, right? You are indented further down the line. Then of course they will be executed first, okay? So the deeper you are in the nest, right, or the more indents that you have, right, the more those sequence of statements have to be executed first, right? Because uh, yeah, it will start always at the deepest nest or the rightmost indentation, those groups of code. After that, it will start from inside and out, right, on each line, and then we'll see if the arguments are expressions, then it will execute that first. But really, you don't see that one a lot, right? Because most programmers try to limit nesting to three or four. Three or four. That means nesting will be up unto four indents. So if you have if here, so another if, and another if, and another if. So this is the base level, first, second, third, and fourth nest level. Okay, so the deeper you go, the higher the priority, right? And each line it will always go from inside and out, right? That's how Python works. And then if there are expressions in those arguments, then it will execute those things as what, three or four. There you go. Yeah, so I hope that was clear. Let's see. Types of operators, yep. So this is just explanation. All the basics can work, comparison, of course, and logical. We have this one. Okay? These are their proper name, by the way. Logical negation, conjunction, and disjunction. These words are not used a lot, okay? They often just use and or directly instead of logical conjunction and logical disjunction. So you don't see these things often discussed in uh, forums or help sections somewhere. Okay, so this is a short circuit evaluation, right? So what does this mean? Um, hmm. So for the and or, right? Remember the condition where um, so and is always true, can only be true if both of the conditions are true, right? But you can also read it this way. It will be false whenever any of the left or right conditions are false, right? It's still the same. It still matches. It's still the same thing with the one I said earlier. But the difference is that you are specifying that one of them should be false. So what does that mean? It means that if you are trying to compare something, right? Nick, on the other hand, is false, and you are uh, using an AND operator. It doesn't really matter whether Brian attends or not. Since the beginning, since the first condition was false, it will always be false, right? So why are we asking for Brian when Nick was not even here, right? No matter where Brian is, Nick is not here, so we cannot proceed with the session, right? So it's automatically false. So meaning, instead of um, using resources to evaluate the condition here, why not just skip and then just go directly to make it false? This is the point of the short circuit evaluation. Okay. In more practical sense, you can do something like this. What if the left condition was uh, is 4 greater than 3. Okay, that's a very simple one. But if you're raising an and then you have the right condition, is 9 less than uh, complex mathematical model here, right? I don't know. I'm just throwing off numbers here. It's not really correct. Let's say 10 tangent. I don't know. Maybe 5 or 10 over 5. Okay, 5. Oh, wait, sorry. Below. No, 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 no. 5. And then you multiply that one by pi, whatever pi is, and you will have some power of whatever exponent is 10 to the power of what? Pi to the power of 10, maybe 10 times negative e, whatever e is, epsilon, right? So this is rather complex, and it consumes resource to actually evaluate this one and see if this one is still true, right? But since automatically, right? I mean, I should make this one false. Since automatically the left one is equals to false, whatever the result of this is actually irrelevant because the answer is already false. The comparison, right, is already false when you are using the AND operator. That's what we're trying to make sense here with the short circuit evaluation. Do you need to know this one? Not really, but it just additional knowledge that you get, right? And something that goes on in the background. So we can just go ahead and um, skip that. Okay. I think um, since we only have an hour more to go, I think I'll have to skip the exercises for now, if that's alright with you guys, and just proceed with the discussion proper. Um, I'll send you guys the exercises and activities later on via LMS, and then you can just answer that one, and we'll answer them together next week. All right? We'll answer the things that you were confused with, the ones that you can't answer. All right? Okay, so let's proceed. The while loop is actually pretty simple, right? The while loop is basically the same as the for loop. The only difference is that it operates with a condition. So you say while, and then you put in a condition here. Whether that condition is true or not, it will execute the sequence of code here that you built. Okay, now uh, this condition needs to be true, right? Whatever you do with it, if the condition is true, it will execute these lines of code. Now you might be asking, when will it be done, right? So it will end at the point when condition is false. So that means this can't run infinitely, all right? Once more, this can run infinitely. Okay, and that is something dangerous, and it has happened a lot before, and a lot of programmers have paid a lot because of this, right? um, it might seem something simple, but it's something even experienced programmers can uh, get wrong, right? Especially if the code is getting more complex and the condition is very, very long before it can be evaluated into something, whether it's true or not, right? So when that happens, they often uh, make it more simple or separate the complex process somewhere else and then make the while loop a bit easier, right? Because you want the while loop to always run whenever the condition is false, and only stop when and only stop when it becomes false, right? So let's say we have an example here. Let's say we have a count, right? Count starts from the 0, right? I want, um, I want my name to be printed as long as the count is less than 10. So if I say count is less than 10, right? and I want my name to be printed every time. It's true. Okay? Alright. Now, I'm gonna ask you guys, what do you think will happen if I do this? If I run the code? Anyone? Hello? What do you think will happen if I run this code? Alright, I'm gonna call someone. Let's start with Nick. What do you think will happen? Okay, I think Nick is not responding. Let's go to Felicity. How about you? What do you think will happen with this code? Alright. Oh, okay, yeah. Let's go back to Mike. Okay, since he has an answer.
Um, I think it will run infinitely. And sorry, medyo ano ako, pause ako. Kasi ano, nagkasakit pa lang ako eh.
Okay,
Sorry.
no worries. That's okay.
Ah,
So Nick thinks that it will run infinitely. Alright? Why do you think that is?
um, I think because of the condition is equal to zero, the count is equal to zero. So, just a guess, sorry.
Yeah, it's okay. So it's actually correct because the count is zero and it will always be zero, right? We're not doing anything to count. We're not increasing it. Um, we're not deducting it, right? So it will never be greater than 10, right? Oh, no, yeah, so it will never be greater than 10. That means it will never stop printing, right? Now, this is what will happen if you run it infinitely, right? What's going to happen is that it's going to print something, but eventually it will stop at a certain point, right? So this will stay white, very white if you are in dark mode. It will be black if you are in light mode. And it will not stop until it will produce an error. Okay, now modern systems have a kind of way to identify if something is running infinitely, right? But it's not always a guarantee. There's always a way that it can go on and on forever, right? And it has happened before, and odds are it will happen again in the future by someone else, right? Um, if you're using servers, then it will absolutely cost a lot. If you are, if you have something that runs infinitely like this, so it's always using resources, and every time it uses resources, you'll have to pay for it. So if I were to run this one, right? So modern devices again, it will not blow up. Right? It has a security feature, but let's see what will happen. Okay, so right now it's running, it's not doing anything, but let's see until when will it stop, right? So if I were to scroll down, this would be very, very long. And as you can see, it's still not stopping at any point, right? It's still running until when, I'm not really sure. Okay, let's just wait. Let's give it a moment. Let's see what will happen. Because eventually the memory will be full, right? is that ending it? Mm. It's actually taking a while. Maybe because I'm printing something, so it has a certain output. Huh. Alright, I think it will take too long. Okay. Wait. Alright, so I think it's happening right now because it's not responding. Alright, there you go. So you can't wait for it to become responsive. So it reached a point where it uses up, I think, all of the memory that is allocated for Chrome for this program, right? Oh, okay, there you go. So let's see. Where is it? Still not done. Okay, let's try and manually change. Uh, so what we can do is we can um, interrupt the kernel. So go ahead, kernel interrupt. Restart. Yes. All variables. Yes. Exit page. All right. Let's just reload the whole thing. All right, and that's an example of a Jupyter notebook crashing, right? But we didn't really see any errors. In fact, it didn't even save anything. Okay, here we go. All right. Okay. I thought everything I typed wasn't saved. Let's. What? Give me a moment, guys. I'm having trouble scrolling down. I think there's something wrong with this. Aha, there you go. Okay, so I'll just okay, do this for now. Alright, okay, so I removed all the output. Um, I wanted to see the error, right? What kind of error it will do. So I'm just, let's say, uh, count plus equal to 1. This should run much faster since we won't see any kind of output, right? So if you run this one, but oh no, sorry, that's wrong. We're increasing it. It will reach an end. It's minus 1. There you go. Run. Okay, and it's the same thing as earlier. See, it's busy. Um, let's see how long it took. Right. So it should indicate, the error should indicate how many times it repeated a certain line of code or a certain section of code. So let's see. So if you're doing this on your device, be prepared for it to actually crash, right? You might have to restart sometimes your entire Jupyter notebook. Never mind. But anyways, you should be able to see, uh, you should be able to see the line where it occurred, and then it should show you something like 11,000 repeats or 12,000, depending on your RAM size. So yeah, um, yeah, that's it. Improper use may lead to infinite loop, and it is also called entry control. You might be asking if both the while loop and the for loop are the same, right? Then the for loop should essentially uh, work the same way, right? It should also work with a condition. Actually, there is a condition for a for loop because the actual format of a for loop, right, in other languages is something like this. So you start with for, and then you have the variable, you have the condition, and then you have the um, limit or up until when, right? So in the cases of the string, right, let's take my name for example, Daniel. The limit here is, the limit of this one is 6, 6, right? The I here starts at 81, okay? But since we are, yeah, I or 1, or we can say I to 0 and the limit is 5, it will still access each and every letter. The condition is while I, condition then is I is less than 6, right? In that way, it will, what? If you have a string declared outside, then you can loop over, let's say, sample or name is equals to Daniel, right? So then you can loop over that using this. But you have to manually access the smaller pieces of data on that container, right? So how would you do that? You would um, hello.